Hello, all too soon we've come to almost the end of a full day session with Data Science and Artificial Intelligence program. We are very excited to host the last session, and it's Machine Learning in Health, Heart Disease Prediction. How do you use data to predict certain occurrences in health? We are very privileged today to have Samuel Dakwa Manu, a data scientist from Get Innovised, GmbH. Please, let's welcome Samuel to take us through the last session, and I hope you would enjoy. Please send the link to your friends, ask them to join. It's the last session, and I'm very sure as others have mentioned they've learned a lot, you would also learn something. Thank you. Sami, take over.
Okay, hello.
Yes, I can hear you now. Awesome.
Okay, great. Good afternoon, everyone. I'm Samuel Dakwamenu. I work as a data scientist at Get Innovised, and in my day-to-day activities, I usually work on data visualization and mainly that and data analysis. So today we'll be taking a look at machine learning in health, and we'll be taking an example from predicting the results of a heart failure case, whether the person is going to survive or to die. Yeah. So, but before that, we'll take a look at machine learning itself and what the buzz about all of it is. And if you've heard about machine learning or you've heard all the stuff, AI and all those stuff, what do they actually mean and how is it done? So I hope that by the end of this session, you have a fair understanding of machine learning, the difference between machine learning and AI and all those stuff. So this a quick overview of what we'll be looking at, machine learning, the categories of machine learning and some of the techniques used. And we'll have a few examples of the application of machine learning. And if you want to go into machine learning or learn how to be able to be doing machine learning, I have a few key points that you need to know, the prerequisites of machine learning or of doing machine learning. Okay. So we will start with the question, what is machine learning? What is machine learning and what's its role in the field of artificial intelligence and all of those stuff? So machine learning is just a subset of AI. A lot of mathematics and statistical methods are used to help a system, either a computer, to improve at what it does through training and experience. And within that, there's a subfield that uses neural network. It tries to mimic the brain, the human brain. And that's specially named as deep learning. So when through machine learning and deep learning, machines learn how to gain knowledge. And those knowledge that they get are applied in AI so that you can do all the stuff, amazing stuff that you hear about AI. On a daily basis, we use AI every day on our phones. Usually you just pick up your phone and you unlock your phone with your face. That's AI at work. Your phone has already learned how you look like, and whenever you pick it up, you use your phone to unlock it. As I was saying early on, I mentioned that I really like this definition of machine learning from former Nobel Prize winner Herbert Simon. we all know that learning is a process that is mainly done by humans or natural beings. But how does machines also learn? How do machines also learn? So machine learning is concerned with computer programs that automatically improve their performance through experience. In normal programming terms, people write down the instructions for a computer to follow, so in order to complete a task. But through the use of machine learning, you just give the computer examples of the task that you want it to learn how to do. And through multiple examples of the task, it learns by itself how to complete the task. So we can all attest to the fact that there has been a real buzz about machine learning in recent times. So why do we even need machine learning, right? So some of the ways that machine learning helps us is to develop systems that can automatically adapt and customize themselves to individual users. There are a lot of people on the internet, and there are things that everyone wants it to personalize. Everyone wants to personalize things for themselves. So if you use Netflix, you want to always see the kind of movies that you're interested in. You don't have to search so far to find those kind of movies or other stuff that you are interested in. So it's machine learning also help us to discover new knowledge from large databases. There are certain trends in data that normal data analysis will find it difficult to come about. And one very, should I say, funny example is a marketing analysis that came out that there's a connection between the purchase of beer and diapers. This is something that even if you are a data analyst, you might not directly go to search for that insight. But what they realized was that when daddies or the fathers of babies go to buy diapers for their kids, they grab a beer, and either way around too, when they go to buy the beer, maybe they grab a diaper. So they use this machine learning to come out with this insight, so that whenever they sell diapers, they try to bring a beer fridge close to it so that people can just buy it. And there are certain activities that humans do that are very repetitive. So, and also requires some intelligence. So if you are able to train a computer to be able to do that, it makes it easy to be completed. And there's this bottleneck or shortfall in certain tasks that people want to do, but at the moment, there are not enough skills to complete. So if you are able to show a machine the examples to go through it, they are able to catch up to get the algorithm needed to achieve those tasks. So, and the main question is, why now? Machine learning isn't a very new concept. It goes way back in the 1950s, 60s, 70s. But why it has become so popular today is because of the availability of data. With the advent of the internet, we produce so much data on a daily basis. And also the kind of computing that we have today enables machine learning to take place. And there are a lot of researchers always going into details to find better algorithms to help bring better results out of our data. And a lot of industries are investing into machine learning and artificial intelligence. So it has become the talk of the day now. So I think by now, the main question that might be on your mind is, how do these computers or machines learn? So a typical workflow of one of the algorithms that is used. Usually, for example, you have a set of data that you want to know what the outcome will be. Probably you have about 10,000 dogs, right? And you want to know their breed. With that, you can describe each of the dogs using their eyes, their foot, their fur, their mouth, and everything. You put features of a dog, and you label each one of them. So these features belong to this type of dog and all those stuff. So the machine will take all the features with the label of it. So it will learn every feature and its label. And when you give it a random label or a dog, it will be able to tell you the type of breed that dog is. So the simple workflow is take an input of a features of an object and the label of the object, and you train the machine learning. You train the machine using an algorithm, and the algorithm will be able to classify each of the dogs for you. This is just one way of it. There are several other workflows, but a lot of times this is how it goes. So as I said, there are several ways to go about it. There is supervised learning, where you know the categories, you know the different breeds of dogs. There's unsupervised learning. You don't know the breeds of the dogs, so you give it to the machine to separate it into different breeds. When they're separated, you know that this features belong to this breed of dog, these features belong to this breed of dog. And there's reinforcement learning that allows the machine to learn its behavior based on feedback from the environment. This is typically used in the self-driving cars, so that you punish the machine when it gives a wrong result, and you reward it if it gives a right result. And through that, it keeps learning from its mistake. And there's the semi-supervised learning, which uses a mix of the supervised and the unsupervised learning. We'll go into details of that very soon. So this a typical example of a supervised learning. You have some data that you know. You have apples here. You know that these are apples. You could mix it with different stuff, oranges or something. And you take it through the machine learning algorithm. And through the algorithm, the data will get trained. And when you show it an apple, it will tell whether it's an apple or it's not an apple. So with supervised learning, you know the labels of the data that you have. But when you move to unsupervised learning, you don't know the labels that you have. But through the algorithm, the machine gets trained and is able to determine the pattern in the data based on the attributes of the data. It can tell this group of items are similar and can be grouped as one. The other group of items are similar and can be grouped as one. So that creates a cluster of groups within your data. And there's the reinforcement learning. With that, the machine you are not given the machine is not giving more of examples, but you show the item to it and you ask for a response. What is it? If it gets it right, you reward it. That's the term used for a correct response. You reward it, and if it's wrong, you punish it and tell it what it is. So it will note that is the learning phase. So the next time you show it an apple, it will be able to tell you this is an apple. And this is the reinforcement learning is the process that is used in training self-driving cars. So that when your self-driving car is outside and is driving, so when it sees human, it should be able to tell this is human, so I should stop for the person to cross. If it sees red traffic light, it should stop. If it's green, it should go. So depending on the actions that it takes initially, when you punish it, it means the next time it shouldn't take that action again. If you reward it, it means it's allowed. So in that way, the computer or the machine learns how to behave within the environment that it finds itself. So the semi-supervised learning is a combination of the supervised and unsupervised. So from the start, your data may be so large that you cannot tell the groupings in the data. So you can start with an unsupervised learning. It gives you groupings, and based on the groupings, you can label each of the groups and use it in the supervised learning. So semi-supervised learning is also a combination of supervised and unsupervised. In all these, machine learning come out with some techniques that, or the results of machine learning can be grouped into these main three categories or techniques. There's a classification technique, which means after the machine has learned, or the machine learning model will be able to tell which group that a certain thing belongs to. So when you receive an email, is the email spam or not spam? So the classification model classifies it as spam or not spam. Is this product a book or a farm animal? Is it this or that? The clustering also observes a group of observations and put them into meaningful groups. So let's say you have a bag of grains all mixed up. When you give it to a clustering model, it could tell these grains are rice, these are beans, these are groundnuts. So that's what it does at the beginning. It clusters different observations based on their characteristics or their features. And the regression technique is used to predict a value. That's usually a number, probably based on the features. An example is predicting the age of someone. You could provide the model with an image of a person, and based on the image of so many people that the model has seen, you can tell that, okay, this person is 10 years old, this person is 30 years old or 40 years old. So regression are used to predict the values. So another example is what will be the temperature in Accra tomorrow. It gives a scalar value. Okay, so as I've explained earlier on, classification models are used to train examples that are already labeled. And an example is if you want to predict the breed of dogs, we could create data sets with the features of dogs using their height, their weight, their fur color, ear shape, and the label the examples ourselves. So if we label enough examples for the classification model, we can create a machine learning model that can predict the breed of a new dog that we meet. So this another classification of another type of is a type of classification which categorizes two things into two. So whether it's yes or no, male or female, win or loss, spam or not spam. So the binary classification just considers two things, either yes or no, as the name implies, binary. And we have regression. I've already explained that. It also predicts a value. What will be the price of this building in 10 years? What will be? It predicts the value. And under regression, we have multiple types of regression. We have simple linear regression, which uses one input to predict one output. What is so let's say we are an investment firm, and we have data on our advertising or our investments and the returns that it makes. So the simple linear regression predicts whether if we invest 50 cedis, how much are we going to get at the end? So it's 1-to-1. If we invest 50 cedis, okay, it can predict you get 70 cedis. So what if we multiply that by 10? How much are we going to get? So a simple linear regression takes one input and predicts the output. But that's not always the case. Usually, there are more factors that affect something. So with that, you use the multiple linear regression and you give probably, it's not just your investment that will determine your revenue. Maybe other factors, that the age of the company that you're investing in, the number of staff the company has. So there could be several other factors that affect the return on investment that you get. So with that, you use the multiple linear regression to take care of all the other factors that could affect the returns. So for multiple linear regression, you have several features of an object predicting the outcome of the object of the observation. And clustering also group items into different sections. Okay, I wouldn't go so much into these details. K-means clustering is also one type of clustering. So how many ways that, these are examples of methods that machine learning are applied in. So if you want to determine whether an email coming is spam or not spam, that's how your Gmail or Yahoo Mail is able to determine whether the email you are coming should enter your inbox directly, or whether it should go to your spam mail, or is supposed to go to sponsored or promoted or whatever group that you have in your mailbox. They have an algorithm that has studied the pattern of emails that are spam. So once your email drops in, it looks at certain features of the email and decides where to drop the email. So machine learning is used in language translation, image search, recommendation systems on Amazon, YouTube, Netflix. It's possible to diagnose diseases with machine learning. You are able to detect fraud and also conduct the analysis, the sentiment of people based on their tweets or their posts or whatever that they share digitally that can be used in the machine learning. So machine learning has so many useful applications, and today we are going to see how we apply machine learning in in the health sector, specifically see the result of heart failure cases. So these are some applications of machine learning.
So,
okay.
Let me go back to the other image.
Okay.
So what the machine learning does is it's categorizing the person's face and
yes,
then recording
it's learning the features of the face and recording it. So whenever it sees your face, it recognizes that
it knows that this pattern matches this person.
Yes, and everyone's facial features are unique. Even twins. Even twins is able to determine the difference, but sometimes they make the mistakes.
Okay.
Yeah, even for people who are not twins, it's not always 100% accurate. Machine learning algorithms have an accuracy level. So if it could have 90% accuracy, 80%, it means for 90% of the time it will get it correct. So sometimes you see that. So when machine learning comes in the news as with bad PR, then it means it has made a mistake somewhere. Sometimes it sacks people just like that. Some hiring decisions are based on machine learning and AI. Some people's performance and sacking are based on AI. So, yeah.
Thank you.
Okay. So if you want to get into machine learning, you need to learn some programming, Python, R, Julia, or JavaScript. And don't be so hard on yourself that you don't know enough mathematics. In the real sense, you need a lot of mathematics knowledge to be able to do machine learning. But because of the libraries that people have built, they've done all the mathematics under the hood. So you just use the tools to apply machine learning skills. So if there's a formula that you need to know, let's say, with all the algorithms, they are mass formulas. All of them are a long list of mass formulas, but they have been worked on top of programming languages. So you just use a short command, and it does all the calculations or whatever you need to do. So what you need to be able to do is to interpret the results. If you get accuracy of this, what does it mean? If it's this percent of accuracy, what does it mean? So if you are able to interpret the results, then you are good. But if you are very strong in mathematics too, you can go into researching into the creating of algorithms and all those stuff. So as I put here, intermediate knowledge of statistics and probability, basic knowledge of linear algebra, in the linear regression model, a line, okay. So you should understand some algebra and calculus. And aside the mathematics, you should be able to have the skills to be able to work with data. And with all this, there are a lot of resources available for you to learn from scratch to become a very good machine learning expert. But before we move to the health heart failure prediction, I would like to take some questions first, if there are any. Then we move ahead into the.
I mean, there's some drag and drop in machine learning. I mean, now there's a lot of WYSIWYG things like.
Yes.
Well, I mean, now programming is not as complicated as it is. Is there a way to do drag and drop where I want to do something and I have the opportunity to just drag and drop?
Yes. There are a lot of they are called automated machine learning, auto machine learning. You just have to drag and drop. Let's say, I'll take you through the steps. I think I've already run it. I've already run the notebook with coding on all those stuff. But with all the steps that I'm going to take you through, there are tools. Microsoft has Azure Machine Learning that you can use drag and drop. So you just click, you drag the step on top, the one that you want to do. And so you create something sort of a tree, so that from this step, it should do this, from this step, it should move to this. So you just drag and select the things that you want to select. Maybe you drag the add data button into your canvas and you use it to select your data, and which algorithm that you want to use on your machine learning, or how do you want to split your data. You just drag and select, click and click. When you are done with your tree or your flow chart, you just click on run and it will do everything for you.
Okay, we would like to let's take the question at the end, Sammy. I think it would be better so that we don't drag this. So someone, Fianyeku wants to ask, so what are some of the great projects learning? What are the great machine learning projects for the financial sector in Ghana? So be thinking about it whilst you take us through the practical session. And then I've also posted the Julia programming language, how you can learn. I've posted the resources over there. So please, let's proceed.
Okay.
Wanda is also asking a couple of questions. Please keep your questions coming so that we can answer all. Is fingerprint verification a result of machine learning? Some other ones. So please, let's proceed and then we'll take all the questions at the end.
Okay. So let me minimize this. So to save time, I've run the entire notebook, and so I'll just take you through the processes that are done. So our data set is data on heart attack or heart failure cases, and some people survived, some people died. So based on this data, we want to create a machine learning model so that we will be able to see whether, when we have a case and we enter the details or the attributes of the patient, we will be able to know whether the person will survive or the person will die. So this is what our machine learning model will be about. And so there are certain factors that affect death event, and our data set contains the patient's information, like the age, the sex, the blood pressure, whether the person smokes or not, whether the person is diabetic or not, ejection fraction. There are a lot of terms that are held that I don't know what they are exactly. So there's this creatinine, phosphokinase, and serum creatine. So these are certain attributes that they take from the patients. Okay, so what we do, we start by bringing in, okay, let me start by describing this environment that we have here is called,
hello. Sammy, we can't see your screen, we can only see your presentation. Am I in the wrong slide share?
Me too, I can't see anything.
You still, okay, then let me do a new share. Okay.
Close the other one and then you can do a new share. Okay, now about data. Now I can see something. So let's start.
Okay, sure.
Which is online and which platform is this?
Okay, so this is Kaggle, a platform for data scientists to interact, share data, perform data analysis, data, machine learning, and all those stuff. And they have this environment to be able to run your notebook. Usually machine learning from the start is done in a notebook. It's a digital notebook where you can actually make notes and also run your code in it. So it's called a notebook, and you can run it locally on your machine using software called Anaconda. Or you could use Google Colab. They provide free resources for you to run your notebook with powerful machines. So it's like you get machines that are more powerful than what you have locally to run your machine learning task. So what we have here is a notebook that is being hosted on Kaggle, and they use cells. So each cell can be code or markdown. Markdown is for test, and code is for writing your codes to let your to allow you to work with your data. So in your notebook, you have to import certain things that you are going to work with. As I mentioned earlier, we are using Python as our programming language for the machine learning. And there are stuff that you will need to do that people have, because it's being repeated a lot of times, people have created libraries for them so that you don't have to code everything from the start on your own. So to work with them, you import them.
Okay, sorry, no, I'm online, so I missed.
So you import your libraries so that you can work with them. So here we have NumPy, we have Pandas. It allows us to process our data. And the NumPy also helps us to process data more quickly. So they have long names, NumPy. So, and as we've been using them a lot of time, we give it an alias NP, and for Pandas an alias PD. So each time that we type NP or PD means we are using NumPy Pandas. So these are the basic stuff. And here we come down to import a lot more libraries. So you don't have to concern yourself with this much. If you learn machine learning, you know which ones to use. So there are several algorithms that can be used, and in our work today, we are going to compare the performance of several algorithms. So there is this main library called scikit-learn, and it's created to help you do machine learning. And all the mathematics that you need to do has been implemented in this library. And they also have several type of machine learning algorithms that you can use. So we're going to tell whether the person will survive or the person will die. As we learned earlier, it's a classification problem. So we want to see if the person is going to survive the heart attack or die through that. So with that, we load our data. So we use a simple command, and we give the data a variable heart data. So the name of our data, and this where it is located. So we start by looking at the kind of data that we have. You can see all the columns here, the age, anemia. Sorry, anemia. You see that for most of the columns, we have 0 or 1, 0 or 1. Machine learning is more of mathematics, right? So, and in mathematics, numbers are mostly preferred. So in everything that is done in machine learning, at the end, it's converted to numbers in the end. So you just keep track of how you've coded your labels. So for anemia, or your values, right? So for anemia, and as a general rule, usually you use 0 for negative and 1 for positive. And for gender, 1 for male and 0 for female. So that's a common thing. If you see someone's machine learning notebook that they haven't defined, as you can see here, you can tell that the 0 means negative and the 1 means positive. And for gender, 1 is male and 0 is female. So for anemia column, it tells whether the person is anemic or not. 0 means no, 1 means yes. And diabetes, the same thing. High blood pressure, the same thing. And for sex, yes, 1 for male, 0 for female. Smoking, 0 for no smoking, 1 for smoking. And death event, 1 for survived, 0 for died. So that's the definition that we have here. So after seeing how our data looks like, we move forward to explore our data to understand how it looks like. So we first try to understand, is age and sex an indicator for death events? From the beginning, we are going to explore our data, but the results that we see with our own eyes cannot tell that, okay, based on this, the person or age is directly a factor. You cannot directly tell age is a real or the most significant indicator for death event or not, because that's the reason why we are doing machine learning. We cannot tell by ourselves. The machine learning model will combine all the factors that we have, several of the factors that we have here, or the ones we choose to determine whether a person will survive or not. But before that, we try to understand our data and ask some questions to know more about our data. So we start by asking, is age and sex an indicator for death events? So with that, we extract the age data and plot it to see the distribution of age. And you see that for our patients, we have a lot of people between the ages of 40 and 70 to 80.
Princess,
that's the main age.
My khaki.
And we have less people within the age 40 and also less people older than 80. So we plot to see the distribution of gender per age, and the median age is 60, and for females, the highest age that we see is 95, and for males is, I think, the same thing. And for survival, we see the results based on gender. 44.1% of male who had a heart attack survived, and 20% or approximately 21% of them did not survive. For female, and that's about 50. Okay, that's for females, 23.7%. 71 females survived, representing 23.7% of the entire data, and 34 of them died. So about 70% of women survived. So we move on the age. We combine the age and survival status to see which category of people usually survive, or which age group survive the most and who do not survive. And we see that the people who barely survive are those who are aged 60 years old. And so survival is really between 40 and 60, but at the age of 60, between 40 and 70, but at the age of 60, people who have heart attacks often die. So this further analysis on the age and survival status. I think it's a very lengthy analysis, so I think for some of them I'll just move on. We also looked at how other factors, the other medical conditions affect their survival or death. Okay, analysis. So we took each of the features and analyzed the age distribution and whether the person died or not. So there's also analysis on diabetes. In our entire data, 58% of the people had no diabetes and 41.8% had diabetes. And out of that, 31% of those who have diabetes died and 68% survived. So exploring your data and trying to understand how the features affect each other is it's a step in the process of doing machine learning. It's called exploratory data analysis. You try to understand your data so that in case at the training or results level, if there's a need to work around your data in some way, it's called feature engineering. You have to combine stuff or add more data and all those stuff. At the end, you get a better resource through feature engineering. So it's a very lengthy analysis on the factors that result to whether the person survives or not. So I think without wasting much time, we go straight into the modeling itself. So the first step, as I mentioned, I hope you are keeping track of what you are doing. From the start, you import your libraries, you add your data, you look at how your data looks like, you describe your data, and maybe the next you perform an exploratory data analysis to understand how your data look like. And from there, you come to the training of the machine learning model itself. So to train a model, what we do is we have a certain amount of data. So we split the data into two, use a part of the data to train, or when I mention train, to use it as examples for the algorithm to learn what are the patterns within the data. And after it learns, we use another portion of the data that we split to test the learning, whether did you do well or not. It's just like what analogy can best fit here. It's like giving your child a lot of examples of fruits, about 100 of them, and you give your child 80 of them so that they learn, okay, this is how mango looks like, this is how pear looks like, and all those stuff. So he keeps learning on that, and you keep about 20 of them to test whether they were able to learn very well. And based on the results that you get from the child from that point, it means those 20 he hasn't seen before. So based on the results that he gets from the test, you're able to tell the accuracy, the how precise it is. So it's the same thing with machine learning. You split your data into two, one part to train the model and one part to test the model. So for a start, one thing that you should notice is that machine learning is not quite straightforward. It's an iterative process. You have to do a lot of try and errors. Maybe after you run your model, the results that you got is not good enough. You have to add more data or do something, change the features that you are using. So it's a very iterative process. It's not straightforward that I've done this, and I'm done. You are not done. So until you get your desired results, you keep on to tweak your data, add more features, remove features which are not helping, and all those stuff. So with us, we are going to start with these three features of our data: the time, ejection fraction, serum creatinine. And based on these three features, we are going to give our model the chance to learn about 80% of our data. So that's what we specify here. Test size is 0.2, that is 20%, and the remaining 80% is used as training. So at the end of this results, at the end of the training, we use the test size, that is 20% of the data, to test the model, and the results that we get out of the test will determine how our trained model performed. So what you are going to begin with is a normal logistic regression algorithm to train our data on to see the results. So what we are going to use is logistic regression. We imported it as a library, so we give it a short name here so that we can use it. And this is the simple statement that is doing the training of the machine. This simple statement here. So what you have here is logistic regression.fit. So after this is run, it means the training is done. And when the training is done, we predict the results using the data that we split as the test data. So that's S test. And we use an accuracy to score our data. We use the accuracy of the model to score it. So with that, we use the test and also the results from the training prediction. So I've already run this entire notebook, and our training is already done, and we can see here that the accuracy of this logistic regression is 90%. What this means is that for 90% of the time, the model will be able to determine whether a person is going to survive or die. So this is one way of testing the quality of our model, 90% accuracy score. And there's another way of testing your model to see whether it's able to predict very well, and that is called a confusion matrix. So the confusion matrix tells us how accurate the model is able to predict the desired results based on the true labels. So this is the confusion matrix for our logistic regression model. And for 41 of the results, which were where the heart did not fail, it's predicted correctly that the heart did not fail. So let me, okay. So down here shows our predicted label, and on the left shows the true label. So in cases where the heart did not fail, the model was able to predict correctly that the heart did not fail 41 times. And when the heart did not fail, the model predicted that the heart failed. They made that mistake 2 times. So the actual is heart not failed, but it predicted heart failed 2. And corner here, we have heart failed, but the model said heart did not fail, and they made that mistake 4 times. And in cases that the heart failed, the model was able to predict that the heart really failed. So machine learning model is not 100% accurate, but the best model is the one that is able to predict as you desire, based on several metrics that are used. So for most data scientists, they have a certain metric that they care most about. Sometimes it's the accuracy, sometimes it's the recall, how it's able to predict the truth very well and the false, the true and false well without making false positives and all those stuff. So the prediction is done, but to actually see the results of our model, we can do a test here as we used the time, the ejection fraction, and the serum creatinine. So we've given it, we are using some of the data from our test results to actually see how the model predicts some of the results. So what you have here is, so the table here is the data that we are trying to find results for, and the results here in that order from top to down is from left to right here, shows the outcome of the prediction. So in the case where we had time 150, ejection fraction 25, serum creatinine 1.0, the person did not die. So in the case that the person died was the 4th observation, which is when you come here, is where the person had 11 time 38 ejection fraction and 1.1 serum creatinine. So we can also try with certain parts of our data, let's say 15 to 17, to just see how it does the prediction. So it's going to predict based on this data. And when you run the prediction, we are predicting this test sample. So predict test sample. And this is the test sample that we've printed over here to visually see how it looks like. So when we predict it, it gives us a result in an array. It means a person with these attributes will not die in case of a heart failure. So this is the entire process of coming up with a machine learning model. So it doesn't end in the notebook. In most cases, when the data scientist completes the model, it is exported so that those who create apps, the software developers, the software engineers can integrate the model in the tools that we use. It could be a mobile phone, it could be an app, could be a website, any type of software engineering products, mobile app, web app, progressive web app, whatever platform it is. It could be a device, an IoT device, a speaker like Alexa or something. All those stuff. That's where the results of the model are used in. And on daily basis, you, the end user, you send the results in like we are doing the notebook here. So if it's an image, you send your image and it predicts the results and gives you an output. But because it uses a software, the output is quite different in different scenarios. So it doesn't end there. A lot of times there are a lot of classification models, or for any problem that you have, there are several models, there are several algorithms that can give you a result. So data scientists do not stick to just one of them. They try a lot of them. Sometimes they just work with one in their notebook, and if the result is not desired, they can run another one. But in this case, I tried to run several of them as I imported earlier. So we have the support vector machine. They are all doing the same problem. They are all trying to achieve the same problem, but they all use different approaches or different way to study or to train a model on a data. So usually the results that come out are a bit different. The performances are usually different. So aside our normal logistic regression that we've seen the results and also tested the results, we use a support vector machine to see that also had an accuracy of 90%. We have k-neighbors classifier that's also had an accuracy of 91.67%. So there are several algorithms that were used in this training, and we can compare their results down here. We have logistic regression having 90% accuracy, and there are several algorithms that were used. So out of these, a data scientist will choose the one that has the most desired outcome or accuracy. So there are several other ways to determine the performance of a model. Accuracy is just one of them. It could be precision, could be the F1 score, the recall. But in this training, machine learning training, we just chose the accuracy to see the results. So this is the end of machine learning model for predicting the outcome of a heart attack, whether the person will survive or not. I think we can take some questions now. Hello.
Hello.
Okay, so I think it's time for questions. I think when I ended with the machine learning itself, there were some questions trying to figure them out. Okay, so what are some great machine learning projects for the financial sector in Ghana? Okay, I think I'll speak on the financial sector generally, not just in Ghana. So the major use of machine learning in the financial sector is fraud detection, and it's applied in several ways. For a lot of banks, for some banks, I don't know for Ghanaian banks if that exists, there's a fraud detection on your credit card or debit card, and it studies the pattern that you use to spend your money. Probably it learns that when you when you use the ATM, you don't spend more than this amount of money or something. So in one occasion that something abnormal happens, your card could get blocked. So when it's blocked, you have to rectify stuff in your bank. This is to stop someone misusing your card or something. So that's one way of fraud detection. And sometimes there are transactions among banks that some of them are fraudulent. So based on the data that the bank has, they use that to detect the type of financial transactions that are likely to be fraudulent. Another use is for granting of loans based on the, how should I put it, the profile of a person or the person applying for loan. Usually in the banking sectors have access to a lot of data about people, your work, in certain countries, your credit score and all those stuff, your housing, and they have more information than you that you could think of. So based on that, when you apply for a loan in the bank, they run your profile or your application through their model, and they could either decide to grant you the loan or not. So there's a lot of applications of machine learning in the financial sector. There are a lot of them. I can't speak about all of them. Is fingerprint verification a result of machine learning? I don't think. Yes, for phones, I can say yes, it's machine learning in some way, because you have to register a lot of your fingerprints. It's some sort of recognition. You have to register a lot of your fingerprints to be able to, for the machine to learn the pattern in your fingerprint. So it's some sort of, yeah, machine learning. Where do I get data?
Okay, do we?
Okay, so Kaggle is one.
Have any more? Where do you get the data? Someone is asking where you get the data.
Yes, so Kaggle is one place that you can get data. There's a lot of sources. Let me see. There's data.org. I think that's for the World Bank also. There's World Bank data. There's people store data on GitHub. There's Google also has a search engine that is specifically for data. So whatever your results are, you only get data results. And Kaggle is also a place that data scientists publish their data sets. Sometimes people scrape data from websites and publish them on Kaggle so that people can work on them. So if you come to Kaggle, you'll find a lot of data. And there's a Kaggle version for Africa. It's called Zindi. Let me see. Okay. Zindi, Africa. So it's a community for African data scientists. There is data.org. Are there data science, machine learning jobs, careers in Ghana? Yes. There are a few companies that are into data science and machine learning in Ghana. Some of them, my companies into data science, machine learning. There's Superfluid Labs. So let me see.
And also now, if you're into data science, you can work remotely, working remotely online. And it's the same thing. There is a company called Coding, and they recruit like developers, machine learners for companies outside, and you can be in Ghana, you can still work. So there are a lot of opportunities in that regard as well.
Yes. And a lot of these companies work with foreign agencies. So there are a lot of opportunities, and there are also remote jobs. So if you are into data science to software engineering, you have a wider reach in terms of job opportunities. It's not limited
Okay,
to
so do we
opportunities
have
in Ghana.
do we have any more questions? We are currently running almost out of time. Do we have more questions for Sami? If we don't have questions now, you can unmute and you can tell us about your experience. Sami, I hope you are done. You are done.
Yes, we are done.
Okay, excellent. At least I've learned some machine learning things today. I've learned the classifier. I've learned the different forms of classification of the data, other things. I've learned a lot today, and I think that it's really an eye-opener. Of course, the most important thing is the resources that I've learned, the Kaggle and other sources that people can find their data, and Zindi.Africa as well. So what it means is that there is a lot of resources for you. I mean, this is just the beginning. And to even understand how machine learning works, how your fingerprints work, like the first time when you unlock your phone with your fingerprint, what the phone tries to do is to create patterns for your fingerprint, and subsequently try to match your subsequent fingerprint with what you have done initially. So I think that this is a great learning point for us to start. And I really want to thank all the trainers for today. I really want to thank Afari Nunya. I want to thank Mauto, Stephen Donko. I want to thank Samuel Manu. I really want to also thank all the wonderful people that have joined us today. I want to thank those who have been faithful from the morning. I can see a lot of participants who are faithful. They've been online since morning. A couple of other people have joined as well. Pakwesi has been online since morning. Eunice, other people, Muniora, to all the other wonderful people that have been with us since morning. We have Idrisu has been with us. Genevieve joined us later. We've had some wonderful people who have joined. Patience has joined. Please, let's hear your experience. How was the day? How did it go? And thanks for joining the session. This is a free session, and you know the only thing you can do for us is to give us feedback on how the session went. Please unmute your mic, and then share your experience, how the day has gone. We are closing down. We are closing the curtain.
Okay,
Can
thank
you
you.
unmute? Yes.
My name is Marcus. I think I was on from the presentation on Excel, and I think that right from there, I learned a lot, and I think this is very good. And we've all been hoping and waiting that this will get the videos as well, because some of the things we've learned today, we need to watch them over and over again, so that we can improve, we can practice more. So thank you very much also for the opportunity given us.
Marcus, I see you in Thai. Where do you work?
Is it, oh, that's just a profile picture, actually. But I work in a hospital. I'm a pharmacist.
Oh, okay. Oh, okay. Okay, awesome. Thank you for joining. Okay.